Pre-calc, what's happening? We're done with logarithms other than making those test corrections, so we're moving on to our next unit, which happens to be conic sections. The word conic sections implies coming from a cone. And I'll show you what that means, but there's certain shapes out there that arise from what's called a double napped cone. And we'll get into that more tomorrow. But for today, we have some prerequisite skills. There's some algebra that's going to happen in this section that we need to be good at. And whether you've learned it in Algebra 2 or whether you haven't, I'm going to go through it today and these little prerequisite skills. And we're going to get good at them because we're going to use them. Okay, so without further ado, let's take a little bit of notes today. We are talking conic sections, prerequisite notes. What we are learning today is called completing the square. It's a process that's used to write perfect squares. And by perfect squares, I mean things that are squared. X minus 2, in parentheses, squared. 25 is a perfect square because it comes from 5 squared. So anything that's been squared is called a perfect square, and we are going to force that to happen today. Okay, so that's our goal. Let's take a quick step back. Something else we're going to do is learn about what's called vertex form. Hopefully you remember that from your Algebra 2 days. I'm pretty sure you got it. But vertex form is a way to write a parabola or a quadratic in a specific way that we really like because it's really, really easy. So in general, we have this h and k. And I didn't even write it in here, which is kind of disappointing. But y equals a x minus h squared plus k. That is vertex form. If I was going to say what is vertex form, it's this, where a is just some number, has to do with how wide open the parabola is. H and k, says up here, is our vertex. And notice there's a sign flip. We've dealt with this a few times now. If it's inside the parentheses, minus h, then it comes out as a positive h here. So then here's an example with some numbers. -2, this is a frowny face. It's a bottom opening parabola because this is negative. -2x plus 5 squared, there's your perfect square, by the way, plus 5 plus 4. The vertex, so the very middle of this parabola, would be at -5, comma 4. We don't do a sign flip on this one, just this one. Our goal today is to get things that don't look like this, quadratics that don't look like this, and make them look like this. If I can make them look like this, then it's really easy to find the vertex. Vertex is here, -5, 4, and we can go on, we can graph it, we can find maxes and mins, we can do different things with it. So we like vertex form. Our goal today is to make things look like vertex form, put them in vertex form. The process to make that happen is called completing the square. Okay. So really quick, I just did some algebra to put it in what we call standard form. So standard form, I'm going to do x plus 5 squared is x plus 5 times x plus 5. That's that. I FOILed. Then I'm going to distribute that -2. Okay. Then I'm going to clean it up. There is standard form. Some different notation for it. I usually call it standard form, but some teachers call it y equals form because it's y by itself. It's y equals all this stuff. The function form, calculator form, I've heard them all used, but I will probably call this standard form when it's y equals ax squared plus bx plus c. These are the same. These are equivalent expressions. The one that we started with and the one down here are the exact same equation, just written in a different language. And we've seen a lot of that throughout pre-calculus and then trig, this different language idea. Being able to be fluent between these languages and going back and forth between them is what gives us our math brain and being efficient in using different languages for different problems. Okay, so let's get into the how did I make this happen? So I went from vertex form to standard form, but really the goal of today is going to be able to turn something that's in standard form back into vertex form. We want vertex form. And the process, again, to make that happen is called completing the square. So here's the first thing. We get to control what c is. C, remember I said, is ax squared plus bx plus c. We get to control this number. So I don't like -46. I want to use a specific number, a special number. So I'm going to move the 46 over, just kind of visually, to get it out of my way. And I'm going to create a blank spot for a c value that I choose. And if you've gone through the bell work, hopefully you found the pattern to make this happen. But I digress. I'm going too far forward. Next, to complete the square, to make a perfect square, this leading coefficient has to be a 1. Our trick we're about to do won't work if this is a -2. So what I'm going to do is I'm going to factor a negative 2 off of both of these terms and put it on the outside of some parentheses. Okay. When I do that, I'm changing the signs because I factored a negative 2 off. It's division. Divide this by negative 2, divide this by negative 2, and that's what I get. Now the bell work comes into place. I have this little blank spot for my C value, and I can pick any number I want here as long as I balance it out, and we'll get into that. But if we're smart about this, we can pick a specific value that will complete the square, that finishes that pattern. That pattern is always going to be half of the middle number, half of this number, squared. So half of 10, and I like to do this to write it underneath it, is positive 5. And then we square that. 5 squared is 25. Oh, and I wrote on there, I didn't want to. That 25 is what would go in this little blank spot right here. Okay, so as we move down, I took half the middle number squared, and it looks like this. Now, hopefully you're questioning, what is this thing? Where did 50 come from? I didn't do anything with a 50. Like I added a 25 here, and whatever I do to one side of the equation, I should do to the other side. So why is this a minus 50? Well, hopefully you picked up on it. If not, that's okay. This is one of those mistakes I was talking about that students make all the time on these problems. There's 2 spots where students will mess up. This is 100% one of them. We took half of the middle number and we squared it, and we put it inside of here. But because of the distributive property, negative 2 times 50, negative 2 times 25, that's actually negative 50. So just by placing this 25 in here, I actually subtracted 50 from this side of the equal sign. To balance that out, I'm going to subtract 50 from this side of the equal sign. Whatever you do to one side, you have to do to the other. Okay, that's one of the things students forget. They go through and they complete the square and they do all this, but you can't just go around adding numbers wherever you want because it makes something happen that we like. We have to balance it out, and that's what we're doing to the other side of the equation. So half the middle number squared, because of the distributive property, that's subtracting 50, so I subtract 50 from the other side. Next, this would be factoring, but we can kind of cut a corner here. What 2 numbers multiply to 25 and add to 10? Well, if we played our cards right, if we did the completing the square right, it's always going to be this number, x plus 5, and another x plus 5. We made it a perfect square. We turned it into x plus 5 squared by doing this little pattern thing right here. So half the middle number squared, that would factor to x plus 5 and x plus 5, which is x plus 5 squared. We have the negative 2 sitting out front. We have this minus 46. That only leaves us with one thing to do to get y by itself and be in vertex form, and that's add the 50 back over. And if we add the 50 back over, we get what we started with, which is good, but this thing right here in vertex form. This is vertex form of this quadratic. I could say it's a frowny face, bottom opening parabola, with a vertex at negative 5, positive 4. That's it. That's our prerequisite. That's what we're trying to do today. So let's do a couple practice rounds with it, and then I'll cut you guys loose with that worksheet. Hit pause if you need to, as always, whenever you get stuck in here, or if I'm going too fast, hit pause, and then come back to this. That's one of the benefits of this asynchronous watching videos. So I want you to write this parabola in vertex form, and then actually tell me what the vertex is. Okay. Here's another vocab word. We call this general form. And all the conic sections can be written in general form like this. General form is equal to 0. I was calling standard form equal to y. Y equals all this stuff. General form would be 0 equals all this stuff. That's okay. It's out of order for us. First thing I'm going to do to make this happen is actually put it in standard form. I'm going to get y by itself. I'm going to get everything else to the other side of the parentheses. Check. Next. Or other side of the parentheses. Other side of the equal sign. Apologies. Next, I'm going to vacate the area with 10. 10 needs to be moved out to the other side because I'm going to make room for what's about to happen. And then I'm going to factor a 4 off of both these, whatever this number is. Doesn't matter if this is divisible by it or not. We might get some gross fractions, and we will in our last example, but I want to factor a 4 off of both these. So if I factor a 4 off both these, it should look like this. Not too bad. I vacated the 10, made some parentheses, factored a 4 on the outside of them. Now we play our game. Half of the middle number, which would be 1, squared, which would be 1. After we do that, we would get this. Now I cut some corners here. Let's see what corners I cut, and if you guys can follow along. Otherwise, you guys can show all the steps. Half the middle number is 1. Squared would be +1. I would actually place a +1 inside of here. But because of the distributive property, I actually added 4 to this side of the equal sign. If I add 4 to this side of the equal sign, I would have to add 4 to this side of the equal sign. Okay, but kind of moving ahead, if I have a +4 over here, I know eventually I'm going to have to subtract 4 to move that over to the other side. And that's why I'm getting this 6, 10 minus this 4. So let's see if you can follow with this. We don't have to do it on both sides of the equal sign. This is actually how I would go about doing this. I take half the middle number, which is 1, square it, which is 1, and that's what I would place inside here. Because of the distributive property, I just added 4 to this side of the equal sign. Well, if I add 4 to this side of the equal sign, I could subtract 4 from the same side of the equal sign and not change the problem, right? If you add 4 on one and then subtract 4 somewhere else, you've balanced out what you've done, and that's how actually I would handle this. So I added 4 by placing a 1 in here. I would subtract 4 to balance that out. 10 minus 4 is 6. This is now a perfect square. X squared plus 2x plus 1. If I factored that, would be x plus 1 squared. And notice, it will if we do this right, if we play our cards right, it will always factor to whatever half of this number is. Half of 2 is 1. That's what will always be in here, x plus 1 squared, even if it's crazy growth fraction. Okay? This thing's now in vertex form. Awesome. It said state the vertex. The vertex would be at -1, 6, and we're dancing. We're done. Okay? This one's fraction. I'll let you go through and do this one on your own. If you have any questions, bring them to me, but I'm running low on time here. There's the whole process. Vacate the area with the 6. Divide a 3 out. When we factor a 3, that becomes 5/3 growth, and that's why this is fraction. Half of 5/3, we kind of did this when we were doing our trig stuff. You can double the denominator. It's 5/6. 5/6 squared, you have to square the top and square the bottom, would be 25 over 36. And that's what this is right here, 25 over 36. Because of this distributive property, 3 times 25 over 36 is 35 over 12. 3 and the 36 is canceled. So I just added 35 over, by placing this here, I just added 25 over 12. From there, 25 over 12, if I add it here, I'm going to subtract it here to balance it out. Common denominator, these two, and then just clean it up. We're going to get growth fractions sometimes. Life doesn't always revolve around and seldom revolves around whole numbers, 2 and 3. When we're doing this stuff, we're going to get some fractions. Okay? Very last one. And I'm going to go quick with it. I got to keep this under 15 minutes for my own sanity. Same exact thing, same story here. But one thing I want you to notice, what is being squared here? Not the x anymore, and that's okay. We had y equals x squared, and we did all this stuff. But this one is x equals y squared. So we're still going to complete the square, but we're going to do it with my y's and not my x's. This is going to give us a side opening parabola. Opens to the left or opens to the right. And we'll talk about that at the end, but the process is still the same. This is general form. So the variable that's linear, that there is no squared for, that's the one I'm going to solve for and get by itself. So let's add 8y squared, let's add 32y, and let's subtract 11. Handled. Now we're going to complete the square. Vacate the area with a -11, factor an 8 off of both of these, and it looks like that. Half the middle number, 2, squared 4. I'm placing a +4 inside of here, but because of the distributive property, 8 times 4 is 32. I just added 32. So to balance that out, I'm going to subtract 32 over on the same side. Now this thing will factor. It always factors to half this middle number, which would be +2 squared. All this stuff is good. And now we're actually there. We're this vertex form. Side opening parabola. It's actually going to open to the right. Just like A before told us if it was a top opening or bottom opening parabola, if A is positive, it actually opens to the right. If A is negative, it opens to the left. H and K also get flipped here. Because this is a side opening one, whatever's attached to the y, that's going to be the y coordinate of my vertex. So the x coordinate is actually -43 in this case. H is out here. K is inside here. Don't forget that. There's still a sign flip, but the sign flip happens with the y one, happens with K in this instance. Okay? That should be enough. Right at 15 minutes, a little bit over. Apologize, okay? Watch this video, go through that little half sheet, bring any questions you have to me. The half sheet is due tomorrow by 11:30 p.m., and we're moving on.